Okay, so yesterday we did bases. We did exponential functions with bases that weren't e. Where is it? Right here. And we logged both sides. Okay. We know the derivative of the natural log function. If I said, what's the derivative of the natural log function? You would tell me 1 over x. Okay. It's 1 over x. Okay. We know how to do it when it's the natural log, but what if it's not the natural log? What if it's another base? Like log base 10, log base 4, log base 5. What you do is you rewrite it in natural log form. So does anybody remember, whoops, there we go. Anybody remember the change of base rule from Math 12? So the change of base rule is, I'll write it over here. I'll write it in the middle. Change of base. So if I have a log of base b of x, I can change that to any base I want. Okay, so we're going to change it to the natural log because that's what we're going to do. So it's the natural log. If I'm going to change it to the natural log, it's the natural log of the argument x divided by the natural log of the base of the original function. Do you remember this vaguely? Okay. Why is this good? Natural log of b is a what? It's a constant, right? So you could think of this as 1 over the natural log of b times the natural log of x. 1 over natural log of b, constant, who cares? You just leave it alone. We know how to derive the natural log of x. Okay? So if you're given a function like this where a is any base, first thing you do is you rewrite it as a natural log of x over the natural log of a. And then you derive it. The 1 over natural log of a, you can just pull that out. What's the derivative of the natural log of x? 1 over x. That looks kind of weird, so we'll write it as 1 over x natural log of a. That's all you're doing. Okay, you're changing it to the natural log to something we know how to do. So what if we were doing the log base a of u, where u is some function of x? What's the only difference here? What? Okay, so let's change the base. So we're going to go, okay, change the base. One over the natural log of a stays the same. What's the derivative of natural log of u? U primed over u. Whoops. So if we were going to clean this up, we would just say it's u primed over u natural log of a. You can remember these formulas if you want to. I don't use the formulas. I just remember to change the base. Because if you know the natural log derivative, you can do every single one. Right? And so I just changed the base formula. But if you're doing lots of them, the formulas are useful. So for example, if I say the derivative log base 10 of what? 4x squared. You could just use the formula, which is going to say u primed, this is u. This bit is u. So what's the derivative of that? 8x. So it's going to be 8 x over whatever u is, 4x squared, times natural log of the base, natural log of 10. And then you could clean it up and say, well, it's going to be 2 over x natural log of 10. Or you could just change the base and you'll get the same thing. So the change of base would be natural log of 4x squared over the natural log of 10. And then the 1 over natural log of 10 stays there. And you derive the natural log of 4x squared, which is 4x squared. And then the top is 8x, which then simplifies to that. So if you want to remember the formula, it's helpful, but really you're just changing the base and just going from there. All right, we'll do one more. I'll give you a couple questions and then there's only like 30 minutes of class left. Let's do log base 10 of cos x. Let's find y primed. Okay, so what are we going to do? Do you want to try it on your own? Try it on your own. There we go. There is no reference angle formula. Wait, bring the question. Is that it? -1 over the natural log of 10 times tan? Because sine over cosine's tan. If you don't get that, that's fine. But so that's the simplified version. We okay with that? All right, I'm just going to give you a few practice questions. And then, let's do one more type of example. Just give me one sec.
What happens if I write -10x over natural log of 10? Like it will be the same?
Yeah, that's the exact same. Yeah. Log base 3 of root x over x plus 5. What should we do first? And we're going to find y primed, but what should we do? You could change the natural log. You could change to the natural log. Okay, let's do that. It doesn't actually matter the order. So you want to change to the natural log? So we're going to go the natural log of this junk. I'm not going to write root x. I'm going to write it to the power of a half because that's what we want anyway, divided by the natural log of 3. Yeah? Do we agree with that? Okay. What should we do now? Yeah, I would split them up. So the 1 over natural log of 3 I'm going to pull out. And this argument is going to become 1/2 natural log of x minus natural log x plus 5. Everybody follow that? Now you can do the derivative. And there you go. You can just leave it like that. Thank you. All right, practice questions. Are numbers 47 to 57. 47. Oh my gosh. To 57, page 362. Please.